the K equilibrium value for the addition of HCN to the following aldehydes are in the order. So if we carefully look at the three substrates which are given to us. So in the first structure we have a methoxy group. In the second structure we have no substituent on the benzaldehyde. In the third structure we have an aldehyde added to the benzaldehyde at the para position. So if we try and compare the electronic effects which are exerted by this group. So this methoxide, it exerts a plus M effect. So if we try and draw the resonance, the electrons will be delocalized as such. So this will donate electrons to this aldehyde group, which will reduce the delta positive at this carbon because of the plus M effect. If you look at the second structure, there is hydrogen. The effect of hydrogen can be taken as a zero effect. Now if you look at the third structure now, we have an aldehyde present. So if we talk about the delocalization in the system, we can have this resonance. So in this structure 3, there will be a delta positive created at this point, which will in turn increase the electrophilic nature of this carbon. Okay. So we know that greater the electrophilic nature of the carbonyl carbon, greater is the rate of the addition of the nucleophile to that carbonyl carbon. So we can clearly see that the third structure will be more reactive than the second one, and the second one will be more reactive than the first one. So we have to mark option 1 as the correct answer to our question. Let us look at the next question. In which of the following pair the latter alkyl halide is more reactive than the former in an E2 reaction with hydroxide ion? Okay. So the E2 reaction is going to lead to the formation of an alkene. So students, whenever an alkene is formed, the product stability is one of the major factors which decides the major product. Okay. So if you look at the first option, we can probably try and draw the alkenes which are formed. So the first structure is going to form a more substituted alkene, while the second structure is going to form a less substituted alkene. Okay. So the former alkene is more stable, so the former will be more reactive. Let us look at the second option now. In the second option, in the first structure, we have 3-bromopentane. So this is a symmetric molecule, and any of the indicated hydrogen can be extracted, which will lead to the formation of this alkene. Now if you look at the second structure now, in the second structure, the indicated hydrogen will be more reactive towards elimination. So it is also going to lead to the formation of the same alkene. But students, we know that because of its symmetrical nature, there will be more number of hydrogens which are symmetrical. So the first one will be more reactive because of the kinetic factor. So in this option again, the former is more reactive. Let us look at the third option now. In the third option, from the first structure, we are going to have the formation of an isolated diene. Whereas if you look at the second structure, in the second structure we are going to have the formation of a conjugated alkene. So in this case, the latter will be more reactive than the former because of the conjugated alkene which is formed in this structure. Okay. Let us look at the fourth option now. In the first structure, the indicated hydrogen will be dehydrogenated. And in the second structure, this indicated hydrogen will be dehydrogenated along with the bromine atoms. So if you look at the product which are formed, so in the first structure, we are going to have the formation of a conjugated system again. Whereas in the second structure, we are not going to have the formation of a conjugated system. So again, in this case also, the first substrate will be more reactive towards E2 elimination. So looking at the option, the examiner seems to be interested in that pair in which the latter is more reactive than the former, which is given correctly in the third option, and we have to select option 3 as the correct answer to question number 37. Let us look at the next question now. Question number 38. So we have been given a substrate which is allowed to undergo chlorination on reaction with Cl2H. So which of the following statement is correct about the reactivity order of CH bond? If you look at the substrate which is given to us, we can clearly see that the hydrogen which is labeled as Y will be the most reactive, as the radical form will be in conjugation with both the benzene groups. So Y will be more reactive than the others. Now if we compare X and Z, so X and Z are both benzylic, but the radical formed in Z will have an additional stabilization due to presence of this CH3 group which is present adjacent to it. So Y is more reactive than Z and Z is more reactive than X. And out of the given CH bonds, the hydrogen which is labeled by W will be the least reactive. So we have the correct order of the reactivity towards chlorination in the presence of sunlight on the basis of the stability of the radical which is formed. So if we look at the options, we can clearly see that we have to select option 1 as the correct answer to our question. Let us look at the next question. Question number 39. Nucleophilic acyl substitution is the reaction in which a nucleophile replaces the leaving group from acyl carbon as depicted below. So the Nu minus has replaced the Y minus from the substrate. So the examiner seems to be interested in the correct order of reactivity of different compound in this reaction with the nucleophile. So if you look at the three substrates which are given to us, the first one is acyl chloride. We have CH3COCl. In the second structure, we have CH3COOCH3, which is methyl acetate. So we have CH3COOCH3. And in the third structure, we have a phenyl acetate. So CH3COOPH. Now students, we know that the reactivity of SN2 in these substrates follows the leaving group ability. So greater the leaving group ability, easier is the rate of reaction. So if we try and compare the leaving groups, we have a Cl minus leaving, we have a methoxide ion leaving, and we have a phenoxide ion leaving. So if we try and talk about the stability of these three leaving groups, we can clearly see that Cl minus is the most stable among these species, followed by the phenoxide ion, which is resonance stabilized, and the least reactive will be the one containing the methoxide ion as the leaving group. Okay, so if we look at the options, we can clearly see that we have to mark option 3 as the correct answer to this question. Let us look at the next question, question number 40. So in the given reaction sequence, so we have a ketal which is allowed to undergo hydrolysis. So when this ketal undergoes hydrolysis, the product P formed will be this, plus the ethylene glycol which was used to form the ketal would be regenerated. Now if we talk about this structure P which is formed, it can undergo tautomerism. So the dione which is formed can tautomerize to give us hydroquinone. And now students, we know that this will be the major form of P present in the solution because it is aromatic in nature. Okay. So let us look at the options now. Statement 1, it says P undergoes tautomerism. This is correct, students. Let us look at the second statement now. P can rearrange itself into a phenolic compound. This is also correct, students. We have the formation of hydroquinone or quinol, which is a phenolic compound. If you look at the third statement now, P on tautomerism gives an aromatic compound that gives violet color with FeCl3. This is also correct, students. All the enolic groups, they give us violet coloration with FeCl3. If you look at the fourth statement now, P is a polar molecule. This statement is also correct, students. This molecule is polar. Okay. So if we look at the question now, the examiner seems to be interested in knowing about the correct statements, and we've already seen that all 4 of these statements are correct and we have to select option 3 as the correct answer to our question. Let us look at the next question.